Hi, hello, welcome to another math lesson. We're going to be talking about solutions to systems of equations. This is something that you would have covered last year. We're going to talk about it a little bit more. During this lesson, you're going to learn how to solve simple equations and solve system of equations with quadratics by graphing. That will really be this lesson and the next lesson. Quick vocabulary. An ordered pair or a coordinate pair is a set of numbers or variables written in parentheses that describe a location on the graph. A coordinate plane is just the combination of the x-axis and y-axis that cross at a point called the origin. A solution to a system is a coordinate pair in which the values, when plugged into both equations, make those equations true. This coordinate pair represents the point in which the two equations in the system intersect. So you're looking for an intersection here. A set is a group of defined numbers, variables, etc. Each individual item is called an element. A function is a unique map from the domain to the range in which every input only has one output. Every input only has one output. An intersection is the point in which two graphs cross or touch. Okay. Our system of equations. A system of equations is a grouping of two or more equations in which two or more unknown variables. Sometimes a system is written just as two equations, and sometimes the equations grouped together with a bracket symbol on the left-hand side. All right. So when we have linear lines, so notice I have two linear lines here. We have case one, they never intersect, just like this. That means these lines are described as parallel to one another. I have case two, where they intersect one time. And then my third case is where they intersect infinitely many times. This means they are the exact same line. It's one line laying on top of the other. Now with parabolas, I have a couple different cases. I have one where they never intersect, so it looks something like this. They're never going to intersect. I have the second case where they intersect exactly one time. It'd be something like that. There's my intersection point. And my third case is where they intersect exactly twice. Check right there and right there. Alright, so during this, what we're going to do is we're going to determine if 3, 2 is a solution. So we're just checking if 3, 2 works. So what we're going to do is we're going to remember that this is my x coordinate, this is my y coordinate. I'm just going to plug those into the equations and see if it makes the statement true. So I'm going to say 2, I get to my x, I'm going to replace it with this 3 value. Minus 3 times y, which is 2, equals 0. And I'm just going to say, is this true? So 2 times 3, 6. 3 times 2, 6 equals 0. 6 minus 6, that is a true statement. So I know it works for that one. Now, let's do it for the second one. We're going to plug in 3 plus 2 times y equals negative 8. Negative 4 times 3 is 12. 2 times 2 is 4. That's a negative 12, sorry. Negative 12 plus 4 gives me a negative 8. That is also a true statement. So I would say yes, that coordinate point 3, 2 is a solution to the system below. And you can work with the quadratic as well, but we're going to do exactly the same thing. Is I plug in my y. Anywhere I see an x, I'll plug in negative 1. Anywhere I see a y, I'll plug in negative 4. So I get negative 4 equals negative 1 squared minus negative 1 minus 6. So we get negative 4. Negative 1 squared is 1. Negative 1 times the negative 1 gives me a plus 1 minus 6. I get 2 minus 6 2 minus 6 is negative 4. That works. Okay, now let's do the second equation. I get 2 plus a negative 4 equals 2 times negative 1. 2 plus a negative 4 is negative 2. 2 times a negative 1 is negative 2. That also works. So I know that this one is true. Now I want you to try. Just determine which point is the solution to the system of equations. So we're just going to start with A. So I'm going to say 4 minus a negative 2 equals 6. 4 plus 2 equals 6. 6 is equal to 6. That's a true statement. So we go there. And now we got to check for the second one. So I'd go 4 squared plus negative 2 squared equals 26. 4 squared is 16. Plus negative 2 squared is 4. 20 does not equal 26. So we can cross that one out. Get some more space here. Okay, next one. We get 2 minus a negative 1 equals 6. Let's check that out. Ooh, we can see 2 plus 1 equals 6. 3 equals 6 is not true, so we can cross that out. Now this is the last one. We can say, yeah, this is probably the one. But let's just make sure. Okay, so we have 5 minus negative 1 equals 6. 5 plus 1 equals 6. 6 is equal to 6. That's true. Then we get 5 squared plus a negative 1 squared equals 26. 25 plus 1 equals 26. 26 is equal to 26. That is true, so we know it's that one. Alright, if you have any questions about how we solve those, please come and talk to me or one of our fantastic tutors. We'd be happy to help you. Have a great day. Take it easy. Thanks. Bye.